You're listening to Tiny Little Victories, the podcast that talks to humans who are changing the world. I'm your host, Jennifer Kite Powell, and on today's episode, we're going to be talking about how mushrooms can break down construction waste to make a better, cleaner product. Our guest is Joanne Rodriguez. She's the founder and CEO of mycelial, a company that uses mushrooms to remove toxins from waste using green chemistry. Joanne wants to create a circular bioeconomy, and she's on her way to change the world. Hey, Joanne, how are you?
I'm great. How are you, Jennifer?
I'm so happy to hear your voice, and thank you for coming on the podcast because everybody is going to be excited about how you have created this company that is turning industrial, commercial construction waste into like upcycled construction products from fungi. And how in the world did you come up with that idea?
Yeah, so it's very interesting. I spent decades in the construction products and material manufacturing sector. I'm a former director of sustainability. I like to say recovering because I was trying to green carbon black. Most of the products we made were from petrochemicals, bitumens, so asphalt derivatives. And I knew we had a waste issue there, particularly related to commercial building envelope products like roofing. They were getting burned and buried. In fact, people were shipping it 400 or 500 miles to check a box of zero waste. And it's just so it could be burned. So fast forward.
What?
Yeah, I
Can
know.
we
It was
stop
very
that for a second. You're like burning roof materials, just burning them.
Yeah. I mean, like we would call it waste to energy. Like I air quote it, but I mean, they were. It was getting incinerated. So imagine burning that and having it go up into the atmosphere, plus the footprint of shipping it like 400 or 500 miles. So
I can't believe that that's a practice that's okay.
Well, I mean, to be honest, the dirty secret about waste is it's so inexpensive from a gate fee or tip fee, like what we know. It's so inexpensive to do it. And in some states, it's incredibly inexpensive to do it that like from New York, New Jersey, they'll load it up on train cars and ship it down to Louisiana, Texas. And it's less expensive to do that. So yeah, we turn a blind eye to these industrial waste issues. And that was one of the things that really bothered me. And it still bothers me as I've come to learn the waste side of the issue. And I went into environmental consulting and learned about the power of fungi, their ability to be nature's recyclers, as well as their root structures to be new materials, and decided to throw a handful of spores on some roof shingles and they grew. And I filed a patent and formed a company. So,
Joanne, this is such an amazing journey because I know I interviewed you for a Forbes article, but we couldn't get into all of this for that. But I'm fascinated by the fact that you did what you said. You just threw some spores up there and then decided to form this company and make a patent. So first of all, congratulations to you. And you have funding. And now it's sort of like this amazing thing, fungi, right? It's like they can do so many things. They can become medicine. We can do so much with it. And I love the story because your story, mycelial, is taking those spores that have broke down that material and waste and then repurposing them for new building materials. And that process for you, I mean, you're not a chemist, right? You're not a scientist.
No.
How did you get there to the point where, okay, now we have this product, how can we get it back into the construction market?
Yeah, so I mean, that also goes back to, it's a nod back to my experience. I help co-chair green chemistry. And so, we would meet and look at what chemicals were facing regulatory concerns in North America and abroad. In doing that, it was very clear that there were chemicals that we used in our industry that were going on to watch lists. So plasticizers known as phthalates and heavy hydrocarbons like those coming from petroleum and plastics.
Yeah.
And so there really became a need to understand that we needed to create cleaner pathways, greener chemistry,
Yeah.
to develop our products as well. And then the other part of that is we reduce our need to extract virgin resources from the earth. So in context, 90% of all the materials we make in the world end up as waste. So
Oh
we
my
only
God. It's such an
resource,
incredible high number that we
it's,
don't even think about. Like,
we don't think about it. And so why would we continue to mine critical minerals, dig holes to
yeah.
get rocks, like to make fillers, continue to hit the tar sand so we can get more petroleum to make more plastic? Like, my whole thing is we've got this cache of materials. So how do we resource that? So
Yeah.
like to create a
I
circular
like that.
bioeconomy. Yeah. So like, let's mine what we've already made.
A circular, you hear circular economy, but a circular bioeconomy really takes it down to basically the foundation of what's happening. You said like all of this waste. And these kinds of terms that you're using, green chemistry, I've never heard of that. And this circular bio uh, you know, approach to things, is that something is going to be mainstream? Do you feel like you're part of that? You feel like you're driving that forward? Because to me it feels like you're at the head of where this needs to go.
Yeah, so I can't take credit for green chemistry,
Okay.
fortunately. But I am a practitioner, so it's probably been about 15 years ago.
Yeah.
And I would say, in full disclosure, we work actively with Dr. John Warner.
Okay.
John Warner is one of the co-founders of green chemistry. He wrote the
Oh,
principles of
okay.
green chemistry and founded the Warner Babcock Institute. We work with him actively today, in the material side of our practice to create then these new use paths. And so
Amazing.
the first principle, there's 12 principles. The first principle of green chemistry is no waste. And so, when you think about trying to create more responsible science and more responsible polymers that will do no harm, and think about where we're centered, it's a natural impact for me to continue to practice that, to continue to think
Yeah.
about greener, cleaner ways, to develop chemistry that's as robust
Yeah.
and as financially viable as
Yeah.
what we produce, within the normal confines of chemistry, right? And
It
then, yeah.
Yeah, no, it's so hard, isn't it, to get people to change or companies or industry to change its behavior. And you're talking about things that I immediately, when you were talking about waste and chemistry and then green chemistry and responsible, creation, was I think of DuPont is the first thing that or 3M that comes to my mind. It's like such these huge global companies creating so many products, sticky notes, scrubby pads, reflection paint that goes on the road. And I wonder, like, they have, to me, a responsibility to change that sort of industrialized pollution crap that they've made. And do you think that those companies are like doing that in a little corner, or do you think they're like, sorry, we've got too much money, we're not going to make a change?
No, I think they are. I think
Okay.
they are. I mean, and I think, so when I pull back, I'm always careful to not try to indict the industries. Like, I think
Yeah,
everybody's
I
tried.
can indict. I'll indict the industry for you. Okay.
But I mean, I do think that we've created such an economic model of and margins, right? That
Yeah.
it's pennies on the dollars, half pennies on the
Yeah.
dollars, and manufacturers generally don't want to make the investment to lose that competitive advantage. I think, however, with regulatory coming down on PFAS, with regulatory coming down on microplastics,
Yes.
and we're starting to see overarching, and this is a global thing, and to see overarching regulations coming from Washington D.C. around waste and extended producer responsibility (EPR).
Yeah.
That you're going to see some of these plans that have maybe been discussed in the background a little bit for the last decade start to emerge and really prompt and promote a circular economy, because it's really about, in green chemistry and circular economies, the efficient use of resources, period. I mean, and that is an economic model, right?
A given. It's a given. Efficient use of resources. We spoke with someone a couple of weeks ago that was talking about industrial hemp and how it's stronger. It makes making rope, and it's greener. The crop actually, nourishes the soil. And, Henry Ford made a car out of hemp back in, his first one of his cars. It's like, industry just cannot seem to get into that circular, responsible production, no waste mode. And I just feel like you said, 10 years ago in the back corner, they're talking about it. Like, let's get it out there. Let's
100%.
Yeah. And I think companies like you, like what you're doing is part of that wave. Let's be responsible. Let's have this green chemistry, this biocircular economy. For you, like, you must be so proud of how well the company's done. And so I really want to know, are people receiving this? How are people, when you have customers, are they like, yes, they can see that return on investment? Do they feel better?
Yeah, I think they do. It's very exciting. I mean, as you had said, Forbes announced and captured the announcement on the close of our last seed round.
Yeah. Yay.
We'll be getting, thank you. And we'll be getting ready to go out for Series A early in 2025. But yeah, we had a major partnership announcement with Tarkett. They're one of the largest commercial flooring manufacturers in the world. And the goal is to innovate not only in how we lend solutions to the world around commercial carpet waste, but how we innovate product reuse. And so their team is all in and very excited about this.
I love that. And I love that we have a dog in the background on the show saying, yay, go, my society.
I know. I'm sorry. He very much wants to be in the room where this happens.
You do not need to apologize, because I have dogs. And if you're listening to this podcast, we love dogs. Our producer has dogs. So we're all about keeping it real here on Tiny Little Victories. I love it. How hard is it to put, or long does it take to put spores on a construction material to break it down and then into your green chemistry, which, by the way, that's amazing, and turn it into a product again that you can sell? What's that process like?
Yeah. So when we're decentralizing waste management through the dispatch of mobile bioprocessors. So we take the show on the road so we can continue to reduce and decarbonize the material supply chain. Logistics are a big part of that. So in a mobile bioprocessor, which is basically fancy for an outfitted 40-foot intermodal container that can be plug and play. We create treatments in our facility here outside of Chicago. We can ship them on site. It doesn't have to be sterile. It gets blended with the waste and it goes into incubation for 2 weeks. At the end, we harvest the materials out. We kill the fungi. We create an inert material, and then we can grind or shred that to create to meet the specs of the manufacturers. And then they're putting it into alternatives for other raw materials. So we're intended to be a drop-in ingredient.
So Joanne, you had said earlier that you put this, I love these words you're using, everybody. You take the fungi, it's with the waste, and it goes to incubation and it incubates. Now, is that a fancy word for it's sitting in a room and the fungi are all locked up with special stuff, so they just like go at it?
Yep, they're just growing. So what we do, like, we control what we control in our labs and our production facilities. So we create a really robust treatment, a robust enzyme. We know we're going out into the field to deal with millions of pounds of waste, right? We're not going to sterilize it or pre-treat it. The most we do is get it ground down. But we optimize those natural functions of fungi. We give them what they really want, lean into that. and it grows through very robustly. So all fungi need is a carbon source. That's what they live on in nature. And we're giving them just a different form of carbon. One way to think about it in a very simplistic way is we're making beer, like we're fermenting.
Yes.
So it's
You're
fermentation.
Yes. Fermentate. And I love that you said that. Like fungi eat carbon. That's what they need. I have a log in my backyard that has lion's mane spores in it. And I'm hoping that it will begin to make lion's mane. So in a very basic way, we're talking about a carbon product with the spores, like I have in my backyard, but on this waste. And why does it only take 2 weeks? Because I can't get this lion's mane to grow. So what is the two? It's a natural process, but
Right.
why is it 2 weeks? Like, well, how many spores is needed per like ton or pound of waste to like
It doesn't
go in
take
there
a
and break it
lot.
down?
Yeah, it doesn't
Really?
take a lot.
What?
It's that we're giving it a controlled environment.
Okay.
And 2 weeks today, we actually have plans to improve that. So when I first started, it was 4 weeks. Yeah, we'll improve it from 2 weeks. We're likely to get it down to about 7 days. Because many of the materials we're treating have chemicals that we want to detoxify. We want to allow the fungi the best opportunity to operate and decontaminate or reduce toxins.
So they are eating the toxins. They are pulling
They
out those
are.
toxins.
So they'll break them down. It's bioabsorption, bioconversion is what's the mechanism there, which is photosynthesis. So we learned that in earth science, right? So
yes, we did.
It's synthesizing the chemicals, easy for me to say, but it's processing it and creating something that is not harmful to human and environmental health, which is what makes it ideal to reuse into new products. And what's really exciting, Jennifer, is that we started with this beachhead strategy in the construction and demolition sector to go back to, like, imagine roofs, walls, and waste or roofs, walls, and floors going back to roofs, walls, and floors. Now we're working with commercial compounders who are replacing plastic polymers with our value streams from waste, and that could potentially go into automotive and CPG. So you could have some sneakers that maybe came from your carpet. So we're really starting to see the expansive opportunities as we grow, and there's a greater awareness of what we do.
Joanne, it's so very important what you're doing, and I love the fact that now that product, not just construction waste, but like you said, can then go into replace a product that is extremely bad for the environment, microplastics or polymer, and then you're cleansing that whole chain. So how long is that you think that's going to take? Because I love the idea of knowing that product that I buy, those sneakers, let's talk about sneakers just 1 second. The amount of sneakers that end up in a landfill, huge. Right. But I see a lot of sneaker companies now like Sustainably Made, or this plastic came from recycled, bottles, which is already bad. I want to know that my shoe has nothing in it that is harmful. So that those air cushions that the Hokas make are made from your product eating out that plastic, right? Or removing those toxins. How long is that going to take?
I mean, I don't know. Like I hope 12 months, 18, like within the next, I would hope within the next couple of years we're really, like, people, I have to allow for product development. Like, I can't control that piece, but I think the fact that our value proposition is to turn around an ingredient that they're already familiar with, so they don't have to change their manufacturing process. It's not completely bio-based. Manufacturers who work with us, whether they're in the construction sector or in the tennis shoe sector or in an automotive sector, can now start to get greater amounts of recycled content as well as bio-based ingredients into their formulations without changing their processes is pretty fundamental. And I think where we may have failed in being able to apply these recycled materials to these commercial applications is realizing that in manufacturing, when you change something, you usually have to change like how you make it. So fundamentally, our goal is to make it easy to adapt this and just take these incremental steps. So the incremental steps improve, right? The pennies all build up to $1, and right? So you have to start somewhere. And that's why, like, I would love to say we're going to have it tomorrow, but we don't control our finished product is the ingredient, right? But that's where consumer demand drives it, you know?
Fascinating to refer to your product as an ingredient.
Yeah.
It's a genius because you're right. Like manufacturers don't want to change that process. It's too expensive, the equipment, machinery, you got to get something else. But this is like the way to influence them to say, we can do this without changing everything and still have a better product that they can then go around and tout to their shareholders. We're very green, we're sustainable, all our products are bio-based. It's remarkable, remarkable, Joanne. So I just want to say thank you for coming on the show. I'm so fascinated by what you're doing, and congratulations for building a company and throwing some spores on some roof shingles and changing the world. Really appreciate it.
Jennifer, thank you so much. I really appreciate the opportunity to highlight it. It's always good to talk to you and make this connection.